Hello, Africammers, and welcome to the Africam show. I hope that you're all feeling wild and live because we are live and interactive. So please send through those questions and those comments because the next 45 minutes is just absolute live wildlife bliss. This is possibly, not even possibly, is definitely my favorite part of any Tuesday or Thursday when we do the Wild Moments show. Absolutely love it. And we're starting off here in Tembo Plains. And we've got a little baby hippo just nuzzling the neck of mum there. Casper's third ghost is on board, says happy Tuesday, Trish and everyone enjoying hot coffee and ready for the show. Very nice. I am enjoying some oolong tea. Yes, I'm trying to keep up with all of you and your wonderful drinks as you enjoy the wildlife. April Owl says, good morning, everyone from sunny Connecticut. You have your glass of raspberry iced tea and you're ready for the show. Very nice. Jen Lat is here and says, good morning. Good morning, Jen Lat. Jan Powers says, hi. Hi, Jan. Mindy. Hi, Mindy. You say, good morning, all. You're trying out your new treadmill while watching the show today. Very nice. That's actually what my mom does. Not only with watching the show, when she watches anything, she jumps in the treadmill. It seems to work well, Mindy. Kelly Farrell, you say good morning from Cleveland, Ohio. Hi, Kelly. Jack DeBoer says good morning from Chesapeake, Virginia. Jean Gale says good morning. Hello outside of the foothills, or in the foothills. You have a melting snow and you have coffee. Well, it's nice to know that the snow is melting. It's getting warmer in the northern hemisphere and it is getting chillier down here for us. I think the last 2 days we've been feeling the chill in the air. And the humidity has sort of gone to zero. Karu is here as well. Hi, Karu. Gordon J says, boy, oh boy, I can't wait to see what we have today. Nice. Me too. I mean, just before we start the show, as you know, we have a look at some of the cams and Kirst, who's in the background, surveys all of them. And she said, there's not much going on today, but I do have some hippos. But you know, every time Kirst says that, we always get some awesome things on the cameras. So actually, I don't want to jinx it, but I believe it. Azanegro says, good morning, afternoon, everyone from beautiful British Columbia, where we are now on daylight time permanently. Nice. That's when you know days are getting longer, temperatures are getting higher. All sounds amazing. Yeah, I'm actually quite glad because where I live on my little patio thing, I only really get the sun in the winter. So for the first time in a couple months, I've finally gotten some sun there. It's not a lot, but it's great. And I did sit in the sun for a while. Anyway, we are looking at some hippos and I'm very excited to see this little one not making its way up onto Mum's back. So getting used to the water. The hippos, as we know, can't technically swim. They use, well, you know, they're not exactly aerodynamic in their shape, but they are semi-aquatic and they actually evolved from land-dwelling mammals to be semi-aquatic. And that comes with a whole host of adaptations. Now, unfortunately for them, they can't swim. So technically they can drown if conditions are not right, which is why they especially look for water sources or water bodies where it's not very deep and they have sufficient time to make their way to the surface to breathe. Now, because they can't paddle and things like that, that depth has to be sufficient for them to be able to kick off or like porpoise from the bottom. So when you're little, this means that it can be very difficult if you sink all the way down. So if you can at least hold on to Mum somehow, put a little pressure around her neck, or even better, get up on her back, that definitely helps. But I think this little one or Mum is helping this little one get used to being in the water more and getting an understanding of its body, how its body moves in the water, where it can push off. And you can see that's very shallow where Mum is because she's not floating. She's standing. She could potentially even be sitting in the water. So it's nice and shallow for that little one to learn. You can also tell from the tree that's on its side that it's not very deep at all. Now, when they're tiny, they're going to have to learn how to build up that capacity of being able to hold its breath. Then you can see the little nostrils popping out for a little breath and back under. And those little calves will suckle underwater as well. That was quite the look, Mum. And holding your breath for, like for a hippo, on average, say 5 minutes, they can hold their breath. A little one, not more than a minute. They still need to grow and learn how to do this efficiently. But it's not only about learning. In fact, most of it is physiological. The ability for an animal to hold its breath in general, whilst not an animal, a mammal specifically, is related to the amount of myoglobin that they have in their bodies, or in their muscles rather. And so myoglobin is basically a protein which oxygen can bind onto. And so if you have a high amount of myoglobin in your muscles, then more oxygen can bind to those muscles. So you have a bigger reserve of oxygen, you can hold your breath for longer. So this is something that we see in all diving mammals, so whales, dolphins, but also in semi-aquatic mammals. And hippos do have a high amount of myoglobin, which is one of those things that allows it to stay under for 5 minutes with not much effort. It's all just an adaptation, a physiological adaptation. Now, humans can also stay underwater and hold their breath for 5 minutes, but it takes a lot of effort and a lot of training and has a lot more to do with lung capacity. Imagine all of that, those wonderful adaptations just there, like superpowers, essentially. Jess, is not normal. You say you never knew they couldn't swim. Yes, they're just not built for it. That being said, I say swim in the typical way. So you won't see a hippo swimming because their lives revolve around these, well, they have a semi-aquatic lifestyle, and it revolves around slow-moving water and shallow water. But I do remember a study from a couple years back where they created a model where they can put in different animals and we could determine whether they were able to swim or not. Because for us, when we swim, it's a technique, right? But for animals that walk on all fours, when they swim, they're essentially using that same movement, kind of like doggy paddling. And that computer model showed that hippos could technically swim. It's just that we don't see that because that's not the lifestyle that they have. Asanegro, you said you thought that they would dog paddle, but hippo paddle? Well, kind of. But their legs are so small. Their legs are very small, but it's also, there's other things. Their feet are not webbed sufficiently to be able to move water. Their bodies are heavy and dense. So they're not really suited to swimming. Amber Cole also says, hello, happy Tuesday all. Great to have Trish with us. Oh, great to have you with us. DNC is here from Seattle as well. And oh, because of daylight savings, it's 7 a.m. So you missed you're usually sitting in the dark, right? So now you have some sun. But I find hippos very interesting because of the... Oh, there we go, baby. Hello. Oh, got a little bit of a scolding from Mum there. Almost looked like the baby wanted to get up into the back of Mum. Oh, I love hippos because they're sort of underestimated, or in terms of their ecological role and their evolution and their physiology, their adaptations. we only really think of them as, oh, this animal that we can predictably find at a waterhole, and that they're aggressive and they do have a lot of attacks on humans and things like that, and they're just very territorial because they're so well adapted to their semi-aquatic life that anything outside of this safe zone, being in a water body, is a threat. And so it's no wonder that they're highly territorial, very protective of the water, but also carefully thinking about their survival. And for them, best survival means being in the water. So if they're outside of the water and they encounter something, they encounter a human, they're going to bolt straight for that water. And if you're in the way, that's going to be a problem. Kelly Farrell, you say you've seen them run really fast after boats and you were shocked at how fast they moved. Absolutely. And that is because they're not swimming to chase after the boat. They're literally running. They're running, they're kicking off. So they can, and that can be very intimidating. And they can gallop. They're not just walking. They can gallop. And on land, they can gallop at about 30 kilometers per hour. And that's pretty fast when you're on a little mokoro, a little boat in shallow water. Yes, hello, Egyptian geese. We won't ignore you. Now, what's also quite interesting is that I said mammal specifically when I was speaking about the myoglobin content, that oxygen binding protein that's in mussels. I spoke about mammals specifically because, for example, Nile crocodiles, where we know that they can also hold their breath for a long time, 15, 20 minutes, but that has nothing to do with myoglobin. That's a completely different physiology. So even though they have a semi-aquatic lifestyle as well, their physiology has changed to solve the same problem. I still want to be able to dive. I still want to take advantage of my home, but I need to figure out a way to do it. Well, obviously they're not figuring it out, but natural selection and the movement of genes and things to optimize for their survival figures that out. And crocodiles don't do it the myoglobin way. In fact, they have very low levels of myoglobin. Instead, they have a different type of binding protein, a different type of oxygen binding protein. So still essentially a similar mechanism, but using a different tool, if that makes sense. I love this stuff. That's why whenever I go out to the bush, I think I'm looking at something. I'm looking at Egyptian geese, I'm looking at hippo, looking at giraffe, whatever it is. And you see the animal in front of you, and your first layer of the sighting is just watching, being in awe of the general size, shape, behaviors of the animal. And then when you sit for longer, you start to notice different things. Look at the smooth skin. Wonder what happens when the sun is on that skin for a long time. What are those little beads of sweat? And we start to dig deeper and deeper. And I'm sure this happens to all of you who are watching the cameras as well, especially if you watch them over several years. Then your questions and thoughts about a sighting become more and more and more intricate and more in depth. And that's what I love. Because it's like we're just looking at this Egyptian goose, but actually there are a million processes, adaptations, tiny little microscopic things happening. And the end result is what we get to see with our eyes visually in that sighting. It's so special. Man, I love the cameras. Another good point is that heart rate drops when an animal submerges itself. And that's not just for mammals, but most animals that submerge or dive, like they have a dive reflex that that there is a name for it, that specific dive reflex. I think it might be bradycardia or diving bradycardia. And that's the instinctual reflex that happens when an animal dives that slows the heart rate. So for hippos, ordinarily, their heart rate is between about 90 and 100 on land. And then when they dive, it slows. So when they're diving to hold their breath and stay down there, maybe they have a little bit of nap, it slows to about half that. So actually, that little one is learning about those reflexes as well, in the safety of the water and by mom's side. You know, when Akers said to me, I've only got hippos, I was thinking, oh, I haven't spoken about hippos in a long time. What can I remember about hippos? And then it all just comes out. Anyway, let's give these two a break and let us head over to Mahali, where we have a wet giraffe. Okay, let's see what this giraffe is up to. Oh no. In my head, I was thinking maybe it's a giraffe in a waterhole that's been for a swim, but unfortunately not. It's just a giraffe caught in some rain. Oh no. You look a little bit sad, but maybe I'm just projecting. So I would hate to be in the cold and the rain right now. But this is life for wild animals, whether it's stormy, whether there's thunder, lightning, rain, wind. It's all just part of life. And there's no comparison that exists in the sense that it's not as if a giraffe knows what it's like to be under shelter when it's raining to understand or to feel that there's a preference for that. So it's just another thing that happens. It might be uncomfortable, but uncomfortable compared to it being dry as opposed to being under shelter. Most mammals have different layers of hair that make up their fur, their coats. Some have 2 layers, but most of them have 3. Okay, maybe not even most, but a lot of them have 3 layers of hair. Or the 3 different types of hair, I should say, not really layers. It's not thicknesses that are on top of each other. So there's a downy, warm layer that's very, very close to the skin that obviously assists in insulation and keeping them nice and warm. And then there's a middle layer, which is kind of like half down, half straight, what you imagine as fur, as hair. And then there's a third type, which is called guard hairs. Now, all mammals have guard hairs, but those other 2 layers, they can be a little less of it or a little more of it, but all mammals have guard hairs. And that's what we're looking at now. The patterning on this giraffe, that's a result of guard hairs. And guard hairs are also waterproof. They're stiff, bristle-like, have this waterproofing. Love a bit of thunder. Even got the giraffe's attention. So those guard hairs are definitely going to help the giraffe wick some of the water off, but even they can get soaked because giraffes don't have a preening gland like birds do, or a way to produce oil that they can lift off and rub onto their bodies in certain parts. Whoa, that is a lot of rain. So even with guard hairs, they can still get soaked. But at least they have a bit of protection. I think I'm sensing some discomfort, the increase in rainfall here. But I'm moving around. Maybe it's trying to find a way to relieve that discomfort. Shame. I'm sorry, giraffe. Oh, Jess is not normal. That is an excellent question. You'd like to know if they ever get hit by lightning being so tall. Yes, but it's not necessarily, it's not a simple yes. It's so I have heard about a lot of giraffes. When I say a lot, okay, I have there have been several times I've heard about giraffes succumbing to lightning. So not necessarily struck by lightning because they are tall, but giraffes like open areas. So if we consider that giraffes like open areas, and if lightning is happening when it's wet, in fact, I was at Fort, which is not too far from Johannesburg, but it's where there's a very large impact crater. I think it might be the largest or one of the largest impact craters in the world. And the scientist who I was speaking to, who was an expert in that area, was actually telling me that he also has a game park close by, and that they had lost about 8 giraffes after a storm because they were in an open area. The the lightning struck that open area, and that's where the giraffes were, and they all perished. But when they actually directly get struck by lightning, that also has to do with the open area, and because they are the tallest thing in an open area where there's only really grass and maybe shorter animals. So it does happen. In fact, I remember reading about this specifically in one of my books. I'm actually just gonna sorry, I just grabbed out one of my books here because I remember very specifically reading about giraffes being struck by lightning. Because it was one of those things, you said it just is not normal. It's a bit of an odd question, but we get asked it a lot because they're so tall. Okay, so I found it was actually not specifically about giraffes, but lightning killing animals in the wild in general. And it speaks about the two most common things being electrical discharge. So, when the air is converted into plasma from the heat and energy coming from a lightning bolt, and the mechanical force, which is like the shock wave that's generated from a lightning, from lightning. So not necessarily the height, but this author also says that he knows of rhino, elephant, and giraffe that have been struck directly. And that usually happens in an open area, like we discussed. So definitely can happen. So it is a short yes, but now you have all the context. Not a simple yes. Asadegor, you say a free bath. Yeah, that helps. Unfortunately, it doesn't remove any parasites. They will stick on there. Grumpy old man, I challenge you to make the poncho for this giraffe, but it would take a lot of material. But I reckon if you can start now, and I don't know why, but I feel like you would be excellent at crochet. I think you crochet a whole lot of patches, sew them together in giraffe shape, and then put a waterproof lining. That is just going to look fire on this giraffe. And then whenever we see a giraffe like that, we'll know exactly who made that poncho. It's your ticket to fame, grumpy old man. Absolutely just as normal. I do love a good storm as well. I love the thunder and the lightning. And here in Johannesburg, we have the most epic storms. And in summer, we have these storms around 3 p.m., almost like clockwork. So imagine this, it's still bright, and then those dark clouds roll in. It's not even, well, first you see these huge clouds building, and then they kind of darken, and then the rain comes, and then by, I don't know, 5 p.m., it's all cleared, and we have the most beautiful sunsets. I do love a great storm, but like you, I wouldn't want to be standing out in it like this. Sorry, giraffe, but let us leave you and head over to Hwange Safari Lodge and see if our baboon troop is behaving itself. I think I took too long. Now we have impalas. Oh, there we are. Hi, guys. I feel like we know this baboon troop at Hwange and we know the baboon troop at Lentore. And I can't help but compare them every now and then. The one at Lentore is, I feel like they're naughtier. But we've seen these guys get up to some mischief too. So far, it all seems peaceful. The impalas are foraging without an issue, and I have seen baboons be disruptive to impala herds. They won't alarm at them or anything like that, but they do look a little bit stressed when baboons are shouting and running and things like that. That just sort of sends out alarm bells for the impalas. What are the baboons reacting to? Look at those baboons are getting so close to these impalas feeding and they're barely looking. There was a time in an open area near our camp, I saw it was the first time I saw a baboon kill something. This big alpha male was chasing some other baboons, and it was loud and intense and quite intimidating. And then it was almost like a cartoon. Like they're chasing each other on the ground, chasing each other up the tree, jumping over to another tree, following each other. And then eventually, the baboon that was being chased landed on a branch that could not support him, unfortunately. So he went falling off the branch, hit the ground, and then the alpha jumped on him. They had a fight. The impalas were very upset by this whole thing because they were just running around without kind of staying in their own space. I felt that maybe the impalas felt disrespected, like there was no respect for their personal space. So they reacted in quite a stressed way. Stopped eating, looking up, running, and when one impala runs, other impalas tend to run as well. This herd response. And then that alpha male, after he absolutely clubbed that other male, in the midst of all their jumping and fighting, he just put his jaws around something and lifted out his head up, and he had a scrub hair in his mouth. So I felt that maybe the impalas thought this is way too much for them and they just moved off to a different plane. But here, everything seems very peaceful, although it can change on a dime. I thought I heard some gurgling just now, so I'm just going to be quiet for a few seconds, see if we can hear it again. Now, when I say gurgling, I mean the sort of burping sound that impala rams make during the rut. It is a touch early, but different individuals can feel that surge of hormones at different times. The impala rut is a wonderful example of, and a simple example of the way in which our environment affects our physiology. So during the rutting season, which is more towards this is kind of like the start of where they're going to feel those hormones changing or rising, and it peaks in May. For us, that coincides with shorter day lengths. So what's awesome when you think about the environment and non-living abiotic factors affecting an individual's physiology is that their hormones, so I'm talking about males, sorry, impala rams, so they need to, normally they have mixed herds. So in order to kickstart this rutting process, they need to feel something change that pushes them towards being territorial, defending territories, and getting a mate. Something needs to motivate them. And so hormones are the perfect motivator. So testosterone rises because it's the hormonal cue, the cue for the testosterone to rise is lower or short day lengths. So less amount of light is what triggers the testosterone rising. I just think that's amazing. Like day lengths getting shorter, there's less light. So that for me means that maybe there's a change in vitamin D synthesis. Maybe there's photoreceptors that are linked to the production of testosterone in impalas. But those external environmental non-living factors are there causing hormonal changes in the impala. And as that testosterone rises, they start to show more macho traits, I suppose. And then day lengths get a little longer again, and it's all back to normal. Actually, I think there's a sweet spot. I must double check this, but there must be a sweet spot because this is happening for our autumn, the rut. It goes into the beginning of winter. But then at the peak of winter, day lengths are shortest, but the rutting is pretty completed. So there must be a sweet spot. And once day length gets too low, then testosterone production is no longer rising. I don't know. That's just an open thought there for me. And I mean, there was something about that impala ram that came in the left of our screen that I don't know, was giving off, I've got high testosterone in me. But I could be wrong. Anyway, the baboons have front row seats to this whole show. I love the rut. During the rutting season, you really get to see impala personalities. I don't mean individual personalities, I mean the traits and the personality of the species. Normally, we just think of them, oh, it's an impala. Yes, they're interesting, but it's just an impala. During the rut, you get to really see what an impala is. I love that. Anyway, let us head over to Moella and have a look at some of my favorite animals, some elephants. Oh, the sound. So peaceful. Gentle movement of the grass. Just stunning. And this is the sort of the end of grass being great. We are moving out of our wet season and into our dry season now. I mean, it's still going to take a couple weeks for it to actually feel that way. We had a really excellent wet season, so that means that groundwater is nice and fed, although in southern Africa we don't have any significantly deep aquifers that can maintain rivers at the same level and things like that. But we do have underground water systems, just not large aquifers that you'd see like in South America, for example. So the change in season means that water sources fluctuate a lot and groundwater also fluctuates. Grasses have pretty shallow roots. So their roots are never going to be long enough to actually tap into groundwater. So they will start to die down. And that's okay. That's part of a grass's cycle, life cycle. Die down in the winter, come back up, or die down in the dry season, come back up in the wet season. And elephants love grass. But the problem is that they don't really love dry grass. They like nice, fresh, juicy grass. So at this time, when we're not like in the dead center of the dry season, we're just moving towards it. The next couple of weeks are going to be the last bits of good grass left. If I were an elephant, I'd be focusing my attention on the grasses. In the wet season, an elephant's diet is dominated by grasses. And in the dry season, it's dominated by foliage. And that's also when resources become particularly scarce. So when there's a drought, then they'll also eat tree bark and go after the tree cambium. And if they're really desperate, they'll even eat dry leaves. I love the change of the season because it reminds me of impermanence, and in the wild, everything can change at any time. You are at the mercy of environmental pressures that you have zero control over. There's period feast and famine, where you have to adjust your diet based on what resources are around. And you start to notice the little things, the yellowing of the grass, or the greening of the green grass shooting up, depending on which season we're changing into. But now, moving into autumn for us, moving into that dry season, we're seeing, and you will be able to see on the cameras, the grass is getting yellower. The water holes, they'll still be good for a couple of weeks. And then you might see a slight reduction. They'll start to look a little bit scummy because all that bacteria and things on the surface get concentrated, but it won't be terrible. By the end of the dry season, that's when things look very, very different. You'll also notice that leaves will start to change color, not in the same way that you might see in the northern hemisphere. Our trees are either evergreen or they will drop their leaves. And then we sort of have some in-betweeners who will show some yellowing. And there's a few species that might show some red as well. But we definitely don't have the turning over of color like you do in the northern hemisphere. However, if there are foreign trees, for example, in urban areas, you might see like maples and things like that, then you do get that colorful display. But in the bush, you're not going to see that level of color change. And that's all to do with the plant's adaptation, or the plant adapting to the new season. Different pigments start to, it's basically trying to reserve resources. So there's a part on a leaf, you know, where the leaf joins the stem? There's a little layer of cells there called an abscission layer. And when resources are poor, like a dry season, it activates that layer. And so it can cut off resources at that layer so that the leaf drops off. Before that starts to happen, resources it doesn't happen overnight. So resources start to get pulled inward and no longer go out towards the trees or towards the leaves. And that's what causes the color change. because it's all chemistry happening in the leaves. The amount of water, the amount of sugar, and the pH value of those. Because when we see color, all we're seeing, like you know, is light reflecting off, bouncing off a particular object. So if something is green, then it means that green is the amount that's being bounced off the most that we are seeing. But actually, what pigment is, it's a structure. It's a chemical structure that has that property. So we know chlorophyll is green, which is why we see so much green when we look at plants, but that's because the chemical structure of chlorophyll reflects green and it's absorbing everything else. But as that chemical structure starts to change because there's less sugars and less water, then what it reflects starts to change as well. And sometimes the chlorophyll blocks structures that are just beneath it. And so as those chlorophyll molecules get smaller, maybe a little dehydrated, the colors beneath it start to show. But it also means that if elephants go and are eating this foliage during the dry season, there are less nutrients in it. But luckily for them, they can cover vast distances and go look for the best of the best. During the dry season, you might see them particularly feeding around drainage lines, around water bodies, because that's where resources are a little more abundant for the vegetation as well. So that means when they eat, they're getting just that little bit extra. And they can definitely sense the change in the season, 100%. Every single animal in the world, you included, can sense that. But in the wild, they're a bit more attuned to it because their survival directly depends on it. So they'll be gobbling up as much as possible, I'm pretty sure. Actually, no doubt about that. Picking up marulas, having a feast of whatever marulas are left over. I'm sure they're actually quite a bit now. As much grass as possible, because soon things are going to be dry. But that's okay. That's just the way it is. Let us head over to Tau. We have 2 minutes left. There's some ellies there as well. I always do like to look at Tau. There the ellies go in the distance. And we have the waterbuck very close to us. So do you remember that I told you I was going to go for a paleontology comedy night? I was very disappointed to find out that the jokes were not about paleontology at all, and there were no science jokes. So that was disappointing, although the comedian did make a joke about waterbuck. But it was kind of like a Jerry Seinfeld, what's up with the circle around a waterbuck's butt? And then I declined not to explain. Anyway, that was all I had to contribute or I had to share about the paleontology night with all of you. But I'm glad that we could support the paleontology department here at the university. Jean Gale, you say, so aquifers are a factor? There's so much to learn. There's so much to learn. You're absolutely right. The more I learn, the more I realize how much I don't know. And I kind of love that. But aquifers definitely are a factor for worldwide sources of water. Aquifer reserves are huge. They make a huge difference to surface water we get. And aquifers are not, and they're not like an underground lake. It's literally stored water between cracks and all sorts of things in like porous sections in rock. but there's channels and the different systems are linked to those aquifers. So it definitely makes a difference. And we can get into aquifers next time because our time is up. But Jean Gale, I won't forget because I was actually doing some work on aquifers in South America the last couple months. And it just blew my mind the amount of water that's stored underground in some places. But unfortunately, here in South Africa, we don't have aquifers that are comparable to those ones. But we do have fairly predictable wet and dry seasons and very adaptable animals and landscapes. Anyway, we'll chat about that again next week. But it's time to say goodbye. Thank you all for joining me. I always love spending this time with you. Thanks for your questions and your comments. And I'll see you all on Thursday for Wild Moments. Bye for now.